In previous video of this video series, I told you that the value of curve number depends on specific characteristics of the watershed. Specifically, land use and land cover, or LULC, as you can see over here for short, hydrologic soil group, or essentially soil type of your watershed, HSGs, and antecedent runoff conditions, or ARCs, are the factors that are going to influence the value of curve number. Let's say that we have a study area and we want to find the value of curve number for that specific study area. What do we do? In these types of situations, you will have a table based on a reference. The table looks like this. It has two sections. The left-hand side section over here will tell you land cover and hydrologic condition. For example, open space is one type of land cover. What is open space? Lawns, parks, and things like that are considered to be open space. Another type of land cover could be impervious areas. And impervious areas are paved roads, paved parking lots, and things like that. Now, what is hydrologic condition? So, under some of the land cover features on the tables, you will have notations that specify good, fair, and poor. These are different hydrologic conditions related to a land cover. And then on the right-hand side of this table, you'll find over here, you'll find curve number values for different hydrologic soil groups. Based on minimum infiltration rate of different soil textures, you can classify different soils into 4 different hydrologic soil groups of A, B, C, and D. All right, so you'll find the land cover of your watershed. You'll find the hydrologic soil group of your watershed, and also hydrologic condition. And based on that, you'll have a unique value of curve number over here. Similarly for the fair condition and for the poor condition. This is the typical form of the tables that you will see in the reference book to find curve number for the study area. But right now, let's focus on hydrologic soil groups and define hydrologic soil groups A, B, C, D. Every letter represents a specific texture of the soil. For example, I'm going to start from group A. That represents sand and gravel textures. Similarly, I can write different textures for group B, C, D. All right. Notice that as we move down from group A soils to group D soils, the particle size gets smaller from sand and gravel all the way to clay textures. Now you have a good idea of how different hydrologic soil groups represent different soil textures. But there's another thing that I want you to pay attention to, and that's the drainage condition. Sometimes groundwater table is very close to ground surface. And because of that, the soil type is represented by 2 letters. For example, B/D. Now you're going to ask me, if the soil type in my study area is represented by 2 letters, which one should I consider over here to find a unique value of curve number? B or D or something in the middle? So to answer that question, I will ask you this. Do you know about the drainage condition of your study area? If the soil is properly drained, then you will choose first letter which represents drained condition. If the soil is not drained, then you will choose the second letter to find the curve number. So pay attention that the drainage condition of your study area can impact the hydrologic soil group that you are picking for your study area as well. Now, the last thing that I want to mention is based on different hydrologic soil group and hydrologic condition and land cover, you will end up having different values of curve number in this table. Hypothetically, I'm going to come up with some numbers for open space in good condition for different hydrologic soil groups: 39, 74, 79, and 84. Again, these numbers are hypothetical. So let's say that your study area, the land cover is open space, the hydrologic condition is good, and hydrologic soil group is B. And you have this table with numbers, you will find that you need to use the curve number value of 74 and put it in these equations to be able to find S, or watershed storage.